Neptune-size exoplanet found zooming around nearby young star. A planet about the size of Neptune has been found zipping around a young star about 32 light-years away from Earth, according to a new study. This young system, named AU Microscopii, will allow scientists to study planet formation and evolution and learn more about how planets interact with their stars. The study was published Wednesday in the journal Nature. The planet, named AU Microscopii, completes an orbit around the AU Microscopii star every 8.5 Earth days. The star, also called AU Mic, has long intrigued astronomers. It's located in the Microscopium constellation and part of the Beta Pictoris moving group, a collection of stars. The star named Beta Pictoris has 2 known exoplanets in orbit around it. Astronomers have been searching around AU Mic for evidence of an exoplanet, or planet orbiting a star outside of our solar system, for more than a decade. The cool red dwarf star is only around 20 million to 30 million years old, which is very young compared to our Sun, which is 150 times older. The star is surrounded by a disk of gas and dust debris, the leftover remnants of when the star formed. Thanks to data from NASA's retired Spitzer Space Telescope and its current planet-hunting Transiting Exoplanet Survey satellite, TESS, astronomers have finally struck gold. They've now spotted an exoplanet about 8% larger than the size of Neptune in a quick orbit around AU Mic. The AU Mic system is fascinating when compared to the Beta Pictoris system. Both are the same age and have debris disks around them. However, the Beta Pictoris star is a bigger and hotter A-type star, and its 2 exoplanets are at least 50 times more massive, with Beta Pictoris B and C taking 21 and 3.3 Earth years to complete orbits of the star, respectively. We think AU Mic B formed far from the star and migrated inward to its current orbit, something that can happen as planets interact gravitationally with a gas disk or with other planets, said Thomas Barclay, study co-author and associate project scientist for TESS at NASA's Goddard Space Flight Center in Greenbelt, Maryland, in a statement. By contrast, Beta Pictoris B's orbit doesn't appear to have migrated much at all. The differences between these similarly aged systems can tell us a lot about how planets form and migrate. Although AU Mic is a small star, it's young and active. In July and August 2018, TESS observed the star and witnessed the star releasing many powerful stellar flares. In fact, some of the flares were actually more powerful than some of the strongest ones our own Sun has released. These flares can also cause changes in the brightness of the star. Dips in brightness are something astronomers look for because they can indicate a transit or an event when a planet crosses in front of its star during orbit. This is something that TESS can look for as it stares at different areas in the sky. Follow-up observations by Spitzer captured more transits. These allowed for direct measurements of the planet, while ground-based telescope observations helped the astronomers determine the planet's mass. On Wednesday, NASA's Exoplanet Exploration Program Office released a poster, both in English and Spanish, to celebrate the discovery of AU Mic B. It joins the office's Galaxy of Horrors poster series, initially released for Halloween last year. The poster showcases the flares of fury released by the star that likely lashed the planet with radiation. A nearby look at planet formation. The AU Mic system is close enough to be studied. It's bright, and it has a debris disk and now at least one planet with a direct size measurement. There is no other known system that checks all of these important boxes, said Bryson Kale, study co-author and a doctoral student at George Mason University, in a statement. Astronomers now regard the AU Mic system as a nearby laboratory where they can study how stars and planets form and evolve. Typically, astronomers observe planets after they have formed and have to work backward to determine how they reached their position and orbit around a star. It's believed that planets form from clumps of gas and dust in clouds shaped like disks around stars, but observing a system like AU Mic sheds more light on that process. One of the things we want to understand is, when do planets form, and what do they do in their early days? Barclay said. Studying this planet, and hopefully others like it, can give us insight into how our own solar system formed. This star probably hasn't had time to form small rocky planets yet. It gives us a chance to get a picture of what might have happened before our own terrestrial planets like Earth and Venus formed. The scientists also want to follow up with more observations of the system to learn more about the atmosphere of the planet and determine if there could be a second planet around the star. There is an additional candidate transit event seen in the TESS data, and TESS will hopefully revisit AU Mic later this year in its extended mission, said Peter Plavchin, study author and an assistant professor of physics and astronomy at George Mason University, in a statement. Click subscribe to receive the latest news.